Now, one thing with this course that I can't overemphasize is that it's going to be about learning by doing. And so to learn by doing, you're going to need a Linux install. Ideally, you're going to be able to get to all three of the distros that we're talking about in order to run commands, in order to do experiments, that kind of thing. If you have a spare computer or two laying around and you want to install Linux on that, great, sounds good. Most people don't, well, at least I think probably a lot of people don't. And so in that case, you could run virtual machines. Pretty much every machine of the last 3 or 4 years, maybe 5 years, probably more like 5 years, pretty much every decent machine of the last 5 years supports virtualization. Virtualization is a technology where you could run a computer inside a computer. Yeah, I mean, it's turtles all the way down, right? So you can run a Linux virtual machine on your Windows host, or if you're already using Linux on the desktop, hey, kudos, you could totally do that there too. Mac OS, whatever you want to do, you can run a virtual machine. So in what I'm sure is a welcome change, this section, mostly not talking, is mostly doing. So let's get started. We need to do an installation of Linux, basically. So your best bet for learning this material really is to have Linux at your hands. So that's you got to do that. So to be sure that you're going to need to spend time poking around the GUI and learning how to be productive and all that kind of thing, but we're going to try to get started with the command line. We're going to do a little bit of both, but really it's going to be good. When you click around the GUI, you can learn to be productive. You can learn how to read email, load web pages, install applications. We're eventually going to touch on some of that, but the first stuff, more importantly, is the kind of thing that you need a little bit of help on, and that is basically installation and configuration. For now, we need to actually worry about installing it and getting it up and running. Throughout this course, you may see me flip over to my computer that I'm using for this. It's running Fedora 25, which is the workstation version of Red Hat. It uses bleeding edge software and has a frequent release cycle. Much of what you learn for Red Hat Enterprise is applicable, and a lot of what is in Fedora will eventually make its way into Red Hat. Fedora is a little bit more bleeding edge than Red Hat, or not, depending on the needs of the enterprise. Fedora, Red Hat, get it? Yeah, I know, dad jokes, programmer humor. There's going to be a lot of that, like I say. So remember how I said we're going to learn the 3 different distros? Well, I'm running them as virtual machines here with Virtual Machine Manager under Fedora. Here's my Red Hat Enterprise 7.3, OpenSUSE, and my Debian 9 virtual machines. If you're on Mac or Windows, you can do the same thing with Oracle's VirtualBox. It allows you to run a full computer virtually inside another computer, just like I was describing. Virtualization is something that you should get used to if you haven't seen it before. That's going to come up a lot in your career. It's also super useful for troubleshooting, running tests, and having a learning environment. If you plan to set up each of these Linux distros on a dedicated machine, you can skip this section. If you feel like learning 3 different flavors of Linux at once is too much, well, you can take this course a few times and just focus on the sections that are relevant for the distros that you've picked. So it's a bit like playing through a game multiple times to get the story from all the different perspectives. The material that overlaps between each different distro will only be reinforced, so you'll learn it better. So maybe that's not a bad thing. So enough talking, I promise action. Let's start by installing VirtualBox. If you're more familiar with another virtualization platform like QEMU/KVM, like I'm using on my Fedora 25 installation, well, you can skip this section. Now notice that I've downloaded the DVD version, which has, pretty much everything. You can use the NetInst if you want, but the AMD DVD has like everything. It's like 3.7 gigs. It's everything. It's everything in the kitchen sink. So we're going to turn that on, then we're going to boot this up. Now do note about the right control. So if you look, I can't move my mouse outside of the window now. See, I can move it up to the top, but I can't get the mouse out. If I hit right control, it'll release the mouse. That's because we're at basically the boot screen, and the boot screen doesn't know how to deal with the fact that it's virtualized. If we do graphical install, it's going to boot into a graphical environment. And notice we got this pop-up that says the virtual machine supports a guest OS that supports mouse pointer integration. So that means that Debian is aware of the fact that it's virtualized. And when my cursor, see the black mouse cursor, gets to the edge of the screen, it notifies the host, hey, they hit the edge of the screen, and they tried to keep going, so host, you take over the mouse. There's a really interesting little bit of functionality there. So now my mouse will automatically come out of the window. But remember, if you want to force release it, you can always just use right control. We're going to pick our language. For an extra amount of fun, you can choose Esperanto, but we're going to install in English. This should detect the CD-ROM just fine and load the additional components. This should look a lot like what it looks like when you're installing on bare metal as well, depending on how you created an installation thing, whether you burned the ISO to a CD or you wrote it to a USB flash drive. If you're looking for a good program on Windows to write those ISOs to a USB flash drive, I would recommend Rufus. Rufus will let you write. You remember how I said the ISO doesn't necessarily work on a USB stick? Rufus will let you write in DD, which means it doesn't change anything on the ISO, just writes it exactly as it is. Or you can rewrite it, and it'll sort of give you the option when you're writing the flash disk. So in Rufus, you've got an option of choosing between writing a DD, which means no changes to the ISO, so the ISO has to be aware that it could be written to a USB stick and that way. And then Rufus's other option, which is an attempt at making a CD-ROM ISO work on a USB stick, which doesn't always work. So you've got two options with Rufus, but for virtual machine, doesn't matter. All right, we're going to call it Debian. That's fine. So if we don't care about the domain name, you don't have to set that. Configure the network. Okay, now it wants a password. So we're going to enter a password. Created a user and entered a password. Now this is important because the admin user on the system is different than the regular user, and so something very subtle and important happened just then. Eastern time zone is fine for me. You can choose the time zone that's appropriate for you. It's going to do detect disks. It's going to do some stuff. It's like guided, use the entire disk. Use the entire disk instead of LVM. Use the entire disk instead of encrypted LVM. LVM stands for Linux Volume Manager, or Logical Volume Manager, not Linux Volume Manager, Logical Volume Manager. And LVM, think of LVM as a more advanced sort of disk layout, a more advanced sort of disk thing. So with LVM, let's say that you fill up your disk and you get another disk. With LVM, you can tell LVM that, hey, when the first disk is full, just start writing to the next disk. And it will show up to all of your programs like as if it's just one big storage space. Now, if either of those two hard drives die or become inaccessible, it's going to destroy everything on both disks. I mean, more or less, because you don't know which thing was written where. But with LVM, you can manage that kind of stuff. The entire disk without LVM is simpler, and since this is an introductory course, I'm not going to set up LVM or encrypted LVM, but in the advanced course, we're going to talk a lot more about LVM. This has detected the 21 gigabyte disk that I made earlier. I'm just going to hit continue. All files in one partition. This is totally fine. Now, separate home partition. Again, we're going to talk more about partitions later and why home being separate will make more sense later. You've also got the option of separate home, var, and temp partitions. So home is where all of the user files go. Not really all of them, but home is like your home directory. It's your user folder on Windows. In the Windows vernacular, if you're used to like C users something, it's basically equivalent to that. And in Mac OS, it's, you know, the users folder as well, and then something else. So if home is in a separate partition, you could reinstall your operating system or even boot multiple different distributions of Linux, but have a shared home partition, which is pretty cool. For me, where I like to change things kind of a lot, I like having the separate home partition, and mentally, I just make a note that anything that's really important that I want to keep, I put on the home partition, and then when I, you know, destroy Linux or reload Linux or move to another machine or whatever, I only have to worry about bringing my home partition. But because this disk is kind of small and this is an introductory course, single disk. Yep, sounds good. Finish partitioning and write the changes to disk. Write the changes to disk. Now, if you were installing on bare metal, you may have gotten a warning that, hey, this disk contains a whole bunch of stuff. You may have to delete anything that's there in order to do it, just to make sure. This will destroy whatever is on another disk. If you're dual booting, like if you want to dual boot this and something else, you're going to want to unplug any other operating system hard drives just to avoid the possibility of screwing up. So like if you got a computer and you've got an SSD that has Windows on it and you're going to put Linux on another SSD, just unplug the SSD that has Windows on it until you get through your Linux setup, just to be sure. I mean, if you know what you're doing, it's fine. But I'm paranoid and you're a newbie, so let's play it safe, shall we? It's like, do you want to scan another DVD? No. We can pull everything else we need from the internet. Use the network mirror? No. Yes. This is basically going to pull updates from the internet. So you can tell it no there or yes. It doesn't matter. Do you want to participate in the popularity contest? This is statistical information that's reported back to Debian about what packages people have installed so they know where to focus their efforts. I'm going to tell it no, since they're not going to get any good data from us, but you might consider participating. All right, desktop environment. I'm going to go ahead and pick GNOME. As you can see, there are many desktop environments, and we're going to cover that more in a bit. XFCE, KDE, Cinnamon, Mate, LXDE. KDE is really popular, as is Cinnamon. GNOME is what you find on most things, though. I'm going to leave web server and SSH server off, although we'll probably end up manually installing those later. I'm just going to hit continue. Install the grub bootloader to the master boot record. What is this crazy moon language? Yes, so we'll get to that. But for now, we're just going to say yes, continue. And we can enter the dev SDA, because that's our only option. Just say continue. Installing the grub bootloader. Just remember those words. We'll talk more about it in a minute. Installation is complete. Continue. And it's rebooting. Look, the virtual machine is rebooting, just like a real computer. Now we've got a similar menu to the other menu that we've got. And the menu disappeared automatically because I didn't do anything. But I had another option there. I could have done stuff. Hey, look at that. It rebooted. It remembers who I am. And it's letting me log in. Put in my password. It's good to go. I'm getting some messages from VirtualBox here. I'm just going to close that and that. It's like, there's my Debian desktop. All right, moving right along. We'll come back to this. So I'm just going to do ACPI shutdown, which will gracefully shut the system down, and it will turn off automatically back here when it's done. Which is cool. It's a cool feature. ACPI shutdown. ACPI is a communication mechanism. Like when you touch the button, the power button on your computer, and the computer shuts down. When you touch the button on your physical computer, that's an ACPI shutdown as well. We're just triggering it in software because virtual machine.